So good evening, all of you. Am I audible?
Yes, sir.
Okay then. So yesterday we completed states of matter. So today it is going to be chemical equilibrium. Today's topic is chemical equilibrium, right? So another very important chapter. Yesterday I told you that this chapter is divided into two parts, isn't it? So let us first see first part in this chapter, right? So that is chemical equilibrium. So we'll discuss what is chemical equilibrium and how many types of chemical equilibria are there. Then what is equilibrium constant? How many types of equilibrium constants are there? Then you have to check for relationship between equilibrium constants and what are the factors affecting equilibrium constant. So these are the points we need to discuss in this session, right? So after that, we'll proceed with some numericals as usual. Okay, so let us see. Yes. So let us start this session then. Chemical equilibrium. Okay. Now, what is equilibrium? What is equilibrium? A state at which rate of forward reaction is equal to rate of backward reaction. Okay. Let us suppose a reaction is going on. A plus B gives C plus D. Then C plus D is giving A plus B. So this is a reversible reaction. This is a reversible reaction. So this is rate of forward reaction. This is rate of backward reaction. Okay. Generally, rate of reaction is always proportional to concentration of reactants raised to the power n. Now, in this case, what is rate of forward reaction? Rate of forward reaction is proportional to what are reactants for forward reaction? A and B. Similarly, RF is equal to remove proportionality and introduce a constant KF into AB. So what is KF? Rate constant. What is Kf? Rate constant for forward reaction. Okay. Similarly, let us check rate of backward reaction. So when it comes to rate of backward reaction, then backward reaction reactants will be C and D. So backward reaction. So directly proportional to concentration of D and concentration of D. Remove proportionality and introduce a rate constant Kb. Here in this case, it is Kb. C into D. So this is about rate of reaction and equilibrium state, right? So equilibrium constant with respect to concentrations. Equilibrium constant with respect to concentration. That means Kc. That is represented by Kc. Right. Then how we can determine Kc expression, sir? Let us consider a reaction AA plus BB gives rise to CC plus DD. Now A small letter A, small letter B, C, D are coefficients. Capital letters are reactants and products. Now for this, what is rate of forward reaction? Kf into concentration of A. Coefficient will become power. This coefficient will become power. Then B power B. Similarly, rate of backward reaction is equal to rate constant Kb into what are reactants here? C power C and D power D. Now, at equilibrium, because this is a reversible reaction, then at equilibrium, rate of forward reaction is equal to rate of backward reaction. Okay. Now, what is rate of forward reaction here? What did we get expression here? This is the expression. So Kf into, this is Kf into concentration of A power A, concentration of B power B. Similar rate constant, rate of backward reaction, rate constant for backward reaction into C power C, D power D. Now bring this Kb here. Kf by Kb is equal to, in these terms you bring it here, what it will become? C power C, D power D by A power A into B power B. Now the ratio of Kb by Kb, that is what we call equilibrium constant Kc. Equilibrium constant Kc with respect to concentrations. So C power C, D power D by A power A, B power B. So this is equilibrium constant with respect to concentration. Similarly, in the reaction, if gaseous reactants and gaseous products are present, then we cannot consider concentration. For gases, we have to consider partial pressures. So equilibrium constant with respect to partial pressures. Equilibrium constant with respect to partial pressures. So how we can determine same as that of equilibrium constant with respect to concentration. So here it is called Kp. So instead of taking concentration, we are taking partial pressure. Partial pressure of C power C, partial pressure of D power D by partial pressure of A power A and partial pressure of B power B. So what we are doing, only simple molar concentration, square brackets represent concentration. So in place of concentration, we are considering partial pressures, right? So this is equilibrium constant with respect to partial pressures. Then relation between Kp and Kc. Okay, so what is that relationship, sir? Kp is equal to Kc into RT power delta N. Kc is equal to RT into RT power delta N. Sir, What is delta N? Delta N is number of moles of products minus number of moles of reactants. So number of moles of products minus number of moles of reactants. R is gas constant, already you know. T is absolute temperature. T is absolute temperature. So this is one area where you are getting questions in CET exam, relationship between Kp and Kc. Let us see some examples. Let us consider N2 plus 3H2 gives rise to 2NH3, right? For this relationship between Kp and Kc. So Kp is equal to Kc into RT power delta N, right? Then what is delta N here? Delta N is equal to number of moles of product. 2 minus number of moles of reactants. Here 3, here it is 1. Total 4. So that is minus 2. So Kp becomes Kc into RT power minus 2. That is Kc by RT. What does that mean? Kp is less than Kc. For this above reaction, what is the relationship between Kp and Kc? Kp is less than Kc, right? So let us see one more example. Two SO2 plus O2 gives 2SO3. 2SO2 plus O2 gives rise to 2SO3, right? Second Kp Kc relation. First, let us find out delta N value. What is delta N? Number of moles of products. 2. Number of moles of reactants. Here 2. This is 1. So total 3. So this is minus 1. Again, delta N is negative value. So if you are getting delta N negative, then what is relationship? Kp is less than Kc. Kp is less than Kc. Understood? Then PCl5 is dissociated into PCl3 and Cl2. Then what is delta N for this reaction? Here number of moles of products 1 plus 1, 2. Number of moles of reactants 1, that is plus 1. So if delta N is positive, then what is Kp, sir? Kp is equal to Kc into RT power 1. So Kp is Kc multiplied by something. That means Kp is greater than Kc. Done. So this is about relationship between Kp and Kc. Kp and Kc. Then next part, we'll move to next part then. Let us suppose there is a reaction like this. A gives B. For this equilibrium constant, Kc is equal to K. Now we are considering B gives A. Then what is equilibrium constant for this? This will become 1 by K. If the reaction is reversed, then for that reversed reaction, equilibrium constant becomes 1 by K. This is one point. Next point. Case 1. Next, case 2. A gives B. Here Kc is equal to K. Then double it. 2A gives 2B. Then Kc becomes K square. Or if you halved this reaction, is halved. That means half A gives half B. Then Kc is becoming square root of K. Kc becomes square root of K. Similarly, A gives B. For this, Kc is equal to K1. B gives C. For this, Kc is equal to K2. Now, from A to C, means A gives C. Then in such cases, Kc becomes K1 into K2. K1 into K2, right? So next, relationship between equilibrium constant K and reaction quotient Q and Gibbs energy. What is Gibbs energy? G. Okay. Then what is that? Delta G naught is equal to minus RT ln K, natural logarithm. Or delta G naught is equal to convert natural logarithm into log, multiply with 2.303. So you are converting natural logarithm into log value. So what it will become? Minus 2.303 RT log K. Log K. So that is a relationship between equilibrium constant, reaction quotient, and Gibbs energy. Next, relation between relation between Kp alpha and equilibrium pressure. Okay, so let us see what is that relationship. Let us consider one equation generalization. X gives Y plus Z. Both are gases. In such cases, alpha is what is alpha? Degree of dissociation. Kp is equilibrium constant with respect to partial pressures, and P is equilibrium pressure. What is P there? Equilibrium pressure. One more case is there. X gives gas to Y. Example, N2O4 gas gives 2NO2. Is also gas. Then alpha is equal to square root of Kp by Kp plus 4P. Or A is gas, which gives to N moles of B. That is also gas. Then alpha is equal to D minus D by D into N minus 1. What is D, sir? Initial vapor density. Vapor density of equilibrium mixture. Okay, so these are some important points in chemical equilibrium, right? So now let us move to numerical part now. Let's see, KSET 2020 question. What is the question asked from this topic? Question is, for an elementary reaction, for an elementary reaction, 2A plus 3B gives 4C plus D. The rate of appearance of C at time t is 2.8 into 10 power minus 3 mole later inverse second inverse. Mole later inverse second inverse. The rate of disappearance of B at T will be A. Options given are 2 into 2.8 into 10 power minus 3 mole later inverse second inverse. Next option, 1/4 into 2.8 into 10 power minus 3 mole later inverse second inverse. Third option, 4/3 into 2.8 into 10 power minus 3, same mole later inverse second inverse. Last option, 3/4 into 2.8 into 10 power minus 3. Then let us see what we need to find out. Rate of disappearance of B at a time t will be. Rate of appearance of C is given. Okay. What is given? Rate of appearance of C is given. Then what is rate of disappearance of B? Okay. Now what is rate of reaction? First you find out. Okay. What is given reaction? This is the elementary reaction given, that is 2A plus 3B gives 4C plus D. This is the given reaction. Now for this, let us write rate of reaction for this. For this, rate of reaction. That means in terms of B and C. So that is in terms of B, rate of disappearance of B. That means concentration of B is decreasing. That is indicated by a negative sign. So here coefficient will become fraction. That becomes 1/3. Then change in concentration of B by change in time. And with respect to product concentration is increasing. That means plus. Coefficient will become fraction 1/4. Change in concentration of C by change in T time. Okay, then What is rate of disappearance of C is given here. Rate of disappearance of C is given. Rate of appearance of C, that is 2.8 into 10 power minus 3. So this is given. Okay. And what you will get? Minus 1 by 3 to d into d by dt is equal to 1 by 4. What is this value given? 2.8 into 10 power minus 3. 2.8 into 10 power minus 3. Okay. Now what you are getting here? Let us see. What we need, rate of disappearance of B we need. So let us make it a subject, dB by dt is equal to, right? So bring this t here, 3 by 4, 2.8 into 10 power minus 3. 3 by 4, 2.8 into 10 power minus 3. Which option? Fourth option, 3 by 4 into 2.8 into 10 power minus 3, right? This is what we obtained. So this is your answer. So this is how you should solve these questions, right? So this is one question from chemical equilibrium. Next, we will see some other questions also. To see the other models also. If the equilibrium constant for, next question. The question is, if the equilibrium constant for N2 plus O2, this is the given equation. N2 plus O2 gives 2NO. All are gases only. So its equilibrium constant is K. The equilibrium constant for half N2 plus half O2 is raised to NO will be, so A plus B gives 2AB. Half A plus half B gives AB. So I already gave you that expression. Then here Kc is equal to K. If it is halved means Kc becomes square root of K. So it's a square root of K or K power 1 by 2 or K power 1 by 2, right? So this is how we'll get questions based on equilibrium constant. Questions based on equilibrium constant. Then we'll move to next question. So this is a NEET 2020 question. We move to very important question, that is NEET 2020. So answer is this. What is Kc for this reaction? The question is, what is Kc for this reaction? For this reaction, Kc is equal to K. This is, if you consider this first equation, let us consider this first equation. N2 plus O2 gives rise to 2NO. For this reaction, Kc is given, that is K. Okay, so this resembles A plus B gives 2C. The next reaction, half N2 becomes half N2, O2 becomes half O2, 2NO becomes NO. That means half A plus half B gives C. That means a reaction is halved. So in such cases, for this reaction, Kc becomes square root of K, or K power 1 by 2. So that is your answer. Next reaction. This question is asked in NEET 2020. Hydrolysis of sucrose is given by hydrolysis of sucrose. It is given by the following reaction. By the following reaction. What is that? Sucrose plus H2O hydrolysis gives glucose plus fructose. Glucose plus fructose. If, now the question, if the equilibrium constant Kc, if the equilibrium constant Kc is 2 into 10 power 13 at 300 Kelvin, temperature is given, then the value of delta G naught, then the value of delta G naught at the same temperature will be, at the same temperature will be. So now this is the question. Okay. Now what is given there? Kc value is given, that is 2 into 10 power 13. And temperature. We need to find out delta G naught. Change in Gibbs free energy. Change in Gibbs free energy. Okay. How to find out? What is the expression for this? Already I gave you that expression, right? What is that? Delta G naught is equal to minus RT ln Kc, or equilibrium constant. Okay. Then what is R value? What is R value? The state sum matter I gave you in joules. What is that? Minus 8.314 joules per Kelvin per mole. Then temperature is given. What is that? 300 into ln Kc. What is Kc value? 2 into 10 power 13. 2 into 10 power 13. So this is your answer. right? So this is one of the option given in the question. So this is how you need to find out change in Gibbs energy, standard Gibbs energy, right? Then we'll move to next question. The value of equilibrium constant, one more numerical. The value of equilibrium constant the value of equilibrium constant of the reaction. So now the reaction is given. What is that reaction? Hi plus hydrogen iodide, which is in gaseous state, dissociated into half H2 plus half I2. These two are also gases. Is 8.0. So equilibrium constant of this reaction is 8.0. Then the equilibrium constant of the reaction H2 gas plus I2 gas gives rise to 2Hi will be. So we need to find out equilibrium constant Kc for this equation. Options given are 16, 1 by 8, 1 by 16, and last option 1 by 64. 1 by 64. Now how to solve these questions? I've given you all the information previously. Okay. Now, first reaction given. Hi giving rise to half H2 plus half I2. Half I2. Now let us suppose for this reaction, equilibrium Kc constant Kc is equal to K. Let us suppose. Then second reaction. See, you can see here. The reaction is reversed. What is given here? Here these are product side. Now product sides, they are bring down to reactant side. So H2 plus I2. Here half H2, but here it is H2. That means half becomes 1. That means concentration becomes double. Concentration becomes double and reversed. Gives rise to 2Hi. Okay. So doubled means what it will become? What it will become? Then this is the question. Kc is equal to how much for this reaction? Kc is equal to how much? This is the question actually. This is the question actually. Then what you are going to get? So the reaction is reversed. Reversed means if reaction is reversed, K becomes 1 by K. Okay, this is first point. If reaction is reversed means K becomes 1 by K. Then the concentrations are doubled. If concentrations are doubled, then K becomes K squared. K becomes K squared. So for this reaction, Kc is equal to K squared. Kc is equal to K squared. K value we know. Therefore, Kc is equal to 1 by, what is K value? It is given 8. Here you can see 8. So 1 by 8 square. 1 by 8 square is nothing but 1 by 64. So what is final answer, sir? 1 by 64. Which option? Fourth option. So please remember that now the reaction, given reaction is something, let us suppose that equilibrium constant Kc is equal to K. Okay, the next case, reaction is reversed. First thing, reaction is reversed. Reversion means Kc becomes 1 by K, first part. Then reverse reaction, concentration becomes double. That means it becomes K square. So finally you have expression K is equal to, Kc is equal to 1 by K square. Done. So shall we proceed for one more problem? Okay, next question. If just 1 minute. Okay. If the concentration of OH minus ions, if the concentration of OH minus ions in the reaction, or this is given reaction, ferric hydroxide, FeOH taken thrice. This is solid, sir. Then it is dissociated into ferric ions in aqueous solution plus 3 OH minus ions. So this is present in aqueous solution. Now, the concentration of OH minus ions in the reaction is decreased by, no condition, decreased by 1 by 4 times. So concentration of OH minus in this reaction is decreased by 1 by 4 times. Then equilibrium concentration of, Fe plus 3 will increase by, options given are 64 times, then B 4 times, C 8 times, D 16 times. So this is the question. What is the question? In the reaction, we are decreasing concentration of OH minus ions by 1 by 4 times. How many times we are decreasing, sir? 1 by 4 times. Then what happens to the equilibrium concentration of Fe plus 3 ions? Fe plus 3 ions, right? Now, first let us write equilibrium constant for this reaction. So here, 1 minute. So let us proceed for the solution of this question. Kc is equal to concentration of products by concentration of reactants. What is concentration of products? Fe plus 3 OH minus ions, coefficient will become power by concentration of reactant, that is ferric hydroxide. But this is solid, sir. Reactant is solid. So generally solid concentration is considered as unity. That means this entire term becomes 1 because concentration of solid is always considered as unity. So finally what Kc becomes here? Concentration of Fe plus 3, concentration of OH minus whole cube. So this is actually expression for Kc. Now let us include condition there. What is given condition? Concentration of OH minus ions is decreased by 1/4 times. 1/4 times. Then what happens to concentration of 1/4 times in order to when it attains equilibrium, what happens to the concentration of ferric ion? Ferric ion. So that we'll discuss now. So now let us include that condition. Kc is equal to concentration of Fe plus 3. Now what we are making here, concentration of OH minus ion, we are decreasing by 1/4 times. 1/4 times whole cube. 1/4 whole cube. So bring it here. 1/4 whole cube and Fe plus 3 concentration of OH minus. 1/4 cube means 1/64. 1/64 times Fe plus 3 OH minus whole cube. Right? So that means here, what is happening here? What is happening here? So concentration of ferric ions also, in order to maintain that equilibrium, it should be reduced 64 times. How many times you have to reduce concentration of ferric ions also? It should be done by 64 times should be reduced. Right? So this is about concentration, equilibrium constant with respect to concentrations. Equilibrium constant with respect to concentrations, right? So this is how you'll get questions from chemical equilibrium. This is only 50% of this chapter. Still we have more to discuss tomorrow. That is from acids and bases. So mostly they're asking questions from acids and bases, numerical part. Okay, these are also numericals, but from chemical equilibrium, numericals are easy, but more difficult questions will come from acids and bases. So that we'll discuss in tomorrow's session, right? So that's it for this session. We'll meet you tomorrow again. Okay, I'll share these notes in the group. Okay. If you want, you can check it, right? So that's it for this day. Meet you tomorrow. Hello.